Hello everyone, this will be the first of a video series for learning how to create a GraphQL API. For now, we will just focus on the main concepts for a real-world project, understanding each of the libraries needed, and I will walk you through each of the steps to create the first working version of the project. There are many different ways to create GraphQL APIs. The most popular guides include frameworks like Nexus.js for creating full-stack applications, and there are also content management systems that generate a lot of the code for us to make a GraphQL API. But this guide will be more for creating a standalone API, which means that we'll still depend on some libraries, but we'll have more control of the service, thus facilitating the growth of our project later on. This might be especially useful to those of you who already have a full-stack application, like in Next.js, and want to decouple from the front-end setup, or to those who just want to create a service that might be used by different client technologies, and that maybe even have a language that is different than the one that you're using for the API. So the project for this video will be a voting app, which will allow users to create a board, and this board may have multiple items, and these items can be voted. So let's jump right in. So now let's talk about the organization for our project. This is going to be a monorepo because we are going to be needing to have an API and then a client or other things. So for facilitating the deployment, it's better just to worry about a single repository. So I had created the votes app folder, and now I'm just going to create a folder for the API. And in the terminal, navigate to that folder and initialize the package. We can put this as votes API and leave the rest. Okay. So now that we have our API initialized, let's add TypeScript. You might not be very familiar with TypeScript, but it's going to give a huge value to our project later on, making sure that the code that we define makes sense with the data model. And also, it will make sure that all the resolvers of our GraphQL API are compliant with that specification. So now we only need to run npx tsc init and get the base configuration for TypeScript. So now I'm just going to go ahead and open the repository. There, you're going to find a link on the description of this video to copy the same configuration that I'm using for this project. I'm just going to go ahead and select this and paste what I took from the repo. And inside the API folder, let's create another one for the source code. And then index.ts. And in here, console log, hello, Victor. Okay, so now let's open the terminal. And after these got generated, just run node dist. And yep, indeed it's working. Now let's talk about Apollo server. Apollo is a commonly used library for serving GraphQL APIs. It can be used in different ways, such as a standalone GraphQL server, including in a serverless environment. It can be also an add-on for our application that might already be using Node.js middleware such as Express or Fastify. And it can also be used as a gateway for doing a federated data graph. And more than likely, you have seen or used one of the approaches that I have mentioned. But today, we will use the Express add-on, which is Apollo Server Express, which has a more extensive configuration, but brings the benefit of supporting advanced features like WebSockets, custom middleware, and more. In other words, this will let us configure Express freely. In fact, the Apollo server library uses these under the hood. and projects that start by using just Apollo server sometimes need to swap it out for Apollo Server Express when additional configuration is required. So now in our project, let's install the appropriate libraries for this. So it's going to be yarn add Apollo Server Express in version 3.3.0, and it's going to be Apollo Server Core with the same version. And also we might include Express. It's going to be 4.17.1 and GraphQL version 15.5.3. Now the next thing that we should add, it will be for running our project. So that will be yarn add under development ts now dev in version 1.1.8. And we will also add the .env in version 10. Okay, so now let's go to our package.json, and in here we are gonna add the scripts option, and let's just go ahead and copy all the scripts that are on the repository. You're gonna find a link on the description of this video. And don't worry, not all of them are gonna work, but we will go through each eventually and explain what's going on. The next thing that we are going to do is set up our server. So this is not useful anymore, and let's just import the libraries that we need. So first is gonna be import from Apollo Server Express, and that's gonna be the Apollo server itself, and Apollo Server Express config. We are also gonna be in the need of restarting our server every time there's a change. So for doing that safely, we have a plugin from Apollo Server Core, and that's gonna be drain HTTP server. We are also gonna import Express, and HTTP. Okay, so the next step in here is to create a function to set up everything, and that's going to be start Apollo server. We don't need any parameters for now. And the first thing to do in here is const app express to set up. Then we are also going to be needing to configure the HTTP. Create server. We're going to be passing, we're going to be passing the express to it. And the GraphQL server, that's going to be new Apollo server. And Apollo server expects you to pass type defs and resolvers, or instead you could pass a schema. In our case, we're going to be passing a schema, but since we don't have that right now, let's just define the plugins. So it's going to be the drain plugin, and for this, we need to pass the HTTP server. So let's wait to the server to start. And after this, we need to apply the middleware. The middleware for now, it's the app itself. So now we need a promise to make sure that we are listening to the right port. So to do that, we need to set up a new promise of type void, since it's not going to be returning anything that matters. And in here, we are going to listen to the port 4000 and eventually resolve that promise. Okay, so once our HTTP is ready, it's already listening to the port, we may want to console log to alert that it's already running. So just go ahead and copy the message that we have on the repo. That should be fine for now. So this is going to tell us where our GraphQL API is running. And now that we have the function, it's just a matter of calling it. So let's put it down here. And that's it. So open the terminal. And what's going to happen now is that it's going to fail because we don't have any of the GraphQL schema declared yet. So it cannot start a GraphQL server if we don't have at least the root types. So the next thing that I want you to do is to, well, let's get rid of this for now. To create a resolvers folder in here. And this is where all our schema declaration will live. So now let's create a couple of folders in here. Input, queries. And this is going to help us organize our code. Later on, you can add subdirectories in here for each type if you want, or maybe for each type of operation that you might be doing. It could be a section for updating information or for launching certain things. So just try to organize by the common characteristics that your resolvers have. As you may have noticed, we already have some of the benefits of TypeScript in our code. It tells us the configurations that it's expecting, but now it will truly become relevant to our project. In GraphQL, we know that the declaration of a schema is like a tree. So each leaf or node of data that GraphQL tree, it's going to be validated by TypeScript in our project. So for declaring this schema, we have two approaches. That's a schema first and code first. Let's talk about the first one. The definition of a schema in the schema first approach must be by ourselves. And in there, we need to specify the schema according to the rules of the GraphQL convention. Just like if we were defining a menu of available options in a restaurant, but we also need to create the actual code that resolves those requests. So compared to the restaurant analogy, it will be like teaching all the employees at the kitchen how to create these different dishes. So you're doing the same task 2 times of having to specify what's part of a dish. And the problem is that we are not only in the code maintaining this GraphQL file, but also all our TypeScript source code with the same structure. So that's not ideal, and it will make our project hard to maintain. And on the opposite side, the code first approach, which is what we're going to be using on this project, simplifies things by just requiring to focus on the code so that it generates the right schema for you. So it will follow the GraphQL rules strictly and reduce the time spent on development. And for this, we have Nexus. So Nexus is a schema-first construction library, and it's going to help us a lot in this process. To set it up in our project, just open the terminal. And let's do yarn add Nexus, and the version I'll be using is 1.1.0. And the thing that you are going to notice is that we get an error after the installation. And that's because we are having all the scripts for generating things that we haven't configured yet. So for resolving that, just start adding the configuration. And in here, we're going to need a folder for models. The models are going to be like a mirror or the data model that we have on the database. But the nice thing about this is that it takes it to a higher level of abstraction. It's not just the data that is coming from the database, but there could be some virtual fields coming from other data sources. So this is basically what our GraphQL API is going to be exposing. We may have on the database a lot of fields of a user, for example, password, and that is not something that we want to expose through the API. So we're going to have a different field for this. So in this, let's just add index.ts. And we are going to import from Nexus. For models, we are going to need object type. So let's put a summary of the things we need. We need a user. We need board, item, and finally the vote. Okay, so in here it's going to be const user, object type, name. This is going to be user. And in definition, we get access to this parameter, which is going to allow us to define the different fields of that object. So let's say that it's going to need an ID, string, first name, last name, and eventually it's going to have relations to the other models, but since we don't have those declared yet, let's just forget it for now. So in here, we need to do the same for board. And well, we don't need these two. You may want to give a name, a description, for an item, we can have an ID, we can have content, and last but not least, we need the vote. So let's just copy from above. The difference, though, is that vote is going to map users to the item that they are voting. So in here, instead of having this ID, we are going to have item ID, user ID. Eventually, we can add relationships to the appropriate items. But for now, since we don't have any resolving logic, we can forget about that. So actually, we also need to export all this so that the schema is built appropriately. Okay. And now all we need to do is export this. So that will be basically an index.ts file where we are exporting everything from the models. And we have now to declare the mutations and the queries. So for queries, let's do the same. The difference is that we are not going to define objects, but we are going to define queries. So for that, import from Nexus, and it's going to be query field. Export const. We might want to see the boards that we have. That's going to be, for now, nullable since we don't have data. And also, this is going to be a list. So for doing lists in Nexus, just import list. Of course, the items should not be null on a list, but the list itself can be. Okay. Then to resolve this, we have to pass an asynchronous function. Oops, my bad. And in here, just return an empty list for now. The next thing that we are going to need is getting a specific board. So just copy this. And this is actually just going to be the item. So you can get rid of those and return null. Okay. So let's repeat the process of exporting everything. As you may have seen, it's just taking everything from there. And the next thing to define are the mutations. So in here, we need to allow users to create the boards, the items, and vote for those. And in this case, it's going to be, as you may have guessed, mutation field. And when we create a board, we may want to return such a thing. Then we can copy these for create board item. That's going to return an item. And it's going to return null for now. Just repeat the process. Eventually, we are also going to need arguments for this. I'll get deeper into that later. But right now, we need to make sure that we have the layout of the logic that we are going to be needing. Okay, so now all these exports are going to be taken by Nexus, and Nexus is going to generate the GraphQL declaration that we need. Now, for declaring the schema, we are going to be needing to install another package. So yarn add GraphQL middleware, and it's going to be 6.1.6. So make sure to specify that. And while this installs, let's create a file in source, which is going to be schema.ts and context.ts. So the context, in case you're not familiar with GraphQL, it will be passed down to each of the resolvers in this tree. So it uses this concept, this design of dependency injection. So in there, we can pass the request from Express. We can pass the response details. And of course, any library that we may need down the line with the resolvers. So for defining this context, let's import from Apollo Server Express dist Apollo Server. And then here's going to be Express context. Then let's import from Express. And that's going to be request and response. So now in here, we need to define the interface, the data type of what our context will be, so that Nexus is aware of what the resolver is receiving as context. That will be export context. The request will be request. Response. And then we need a function to create actually the context. So export async function create context. And in here, we are going to be receiving the request of Express. So that's going to be Express context. And that's going to be returning a promise, which partially is going to fulfill the context. Then we just return whatever comes in the request. And response will be request.res and request.rec. Okay, so now that we have created the context, we can go to the schema and configure it. Import from GraphQL middleware. I'll be applying middleware for converting our Nexus into actually GraphQL definition. Import from Nexus. Make schema. From path, then import all the types from the resolvers. And now const schema, it's going to be equal to applying middleware of making schema from types, adding the plugins, and then having as generated outputs a schema and the types. So this is going to be path.join, dir name, schema.graphql. This is where all the specification will be saved. And then typegen, it's going to be path.join, dir name, schema, typegen. Then name doesn't really matter. These will just contain all the TypeScript declarations that we can reuse later on. Nexus, of course, also uses those. And down below, let's define the context type. So the module for these will be require the resolve context. The alias is going to be context. And it's going to be an export of context. Last but not least, let's just add this configuration. Okay, so this is a basic setup. Let's just export it. And there are plenty more options that you can see on the NexusJS documentation. This is just what I usually recommend for the setup. So now that we have these, let's go to index and pass it to the configuration of Apollo. Okay. So now the one more thing that I want you to add is a plugin. We know that we have the Apollo plugin drain for restarting our server, but by default, Apollo is going to try to open just a placeholder from them. And here you can instead place the playground so that you can actually see the documentation and also test your APIs, queries, and mutations. So should be this one. No, my bad. That should be from Apollo Server Core directly. And that's going to be a function. Now, to make this work right, we are going to be needing one more dependency. That's going to be ts node. So while this installs, let's go through the scripts. So right now, you're going to see this generate.prisma. And when we set up later on our ORM, this will become important. By now, just see that we have the generation for Nexus. And basically, this is going to take our configuration under schema. It's going to take all the different nodes in the tree and build the schema for GraphQL. Also, it will get all the type generation so that we can reuse it. on our development. And in here, this script, the post install, it will just make sure to generate both Nexus and Prisma outputs as soon as we install something. So more than likely, it's going to keep failing, but eventually, when we have Prisma already set up, everything will be running fine. So in here, yep, it installed. I show an error. We can ignore it for now. And so now let's actually run. And you can see that it got generated this file. It was already present, in fact, since we have the post install. But yeah, and here's the declaration of the types. So to set Prisma up, let's open our terminal. Let's add Prisma 3.0.2 as a development dependency. And after Prisma gets installed, we are also going to be adding the Prisma client as a dependency. Now we can see that the generation is going to run. And once we have Prisma, we need to do npx Prisma init. And this will create a Prisma folder with a schema file where we can declare all our models. So Prisma actually by default is going to put Postgres, but it's not the only type. It supports other relational databases. So depending on your requirements or preference, you can choose any of the other ones. You can even use Mongo, that as of today is a preview feature, but I just want you to know that it's not locked into just one option. I'm going to use Postgres as preference. You can find here also the .env file, and this is just database connection string. So let's configure a database for this. I had created one previously with Postgres. I'm connecting to localhost, so this is fine, and then votes. And the schema by default is public, so that's fine. Now let's go to Prisma, schema.prisma. You can find more about good practices and advanced features in the documentation. For now, let's just be basic and start declaring some of the models that we need. So the user is going to be needing an ID. That's going to be a string. We need to indicate Prisma that this is an ID, and the default is going to be a CUID. First name, string, and this is going to be for last name too. You may also need an email. So let's just put things in here, and more than likely, it should be good to put unique. Password. That's going to be a string too. Whoops. Then model, board, we can reuse this. It's going to have a name. It's going to have a description. And it will have relations to other items, but let's declare those first. So model item, it's going to be an ID. It's going to have content. Oh, and also item is going to have a relation to the board. So you can use board ID, which is going to be a string, board type board. And if you, like me, use Visual Studio Code, Prisma has this pretty cool extension that you can use for auto formatting. So if I run this now, you can see that it completed the rest of my statement using the right variable. So that's a pretty cool feature of VS Code with Prisma. It definitely helps you speed up the development process. So in here, the only thing that I have left to do is fix these two items so that it's more human readable. And let's add model, vote. And vote is going to be, as I mentioned previously, a relation between a user and an item. So we're going to need a user ID, string. Oh no. Oh yeah, it's a string. And then item ID. And that's going to point to a user and an item. But since we don't have a single ID in here, we need user ID and item ID to be the identifier. So let's just format, and boom, magic. So now let's go to user, make this votes. It's a list of votes. And in here, let's check. Okay. So let's just confirm with the models in case we skip anything. Okay, seems like we have covered. And now under the local development, Prisma has the command npx prisma dev. Note that this is only intended to be used in development mode, and that's because it will create a shadow database to make sure that the changes that you are making will not affect in a negative way the structure that you have on the database. And if that passes, it will actually apply it to the database that we configured on the .env file. So I will describe later in this video series how to do it at production level. But for now, let's just run this. Oh, sorry. It's Prisma migrate. Yeah. So this is going to create a folder inside the migrations folder that is about to show up here. And whoops, seems like I already had one. Yeah, no worries. So in your local, you should already went straight to the question of how you want to name your migration. And once that's done, it will create this record in here with the actual SQL that it was run. Also, there is a possibility to just create the file and not run it. And that's by adding the flag create only. So you may want to do that in the future later on. If you have, let's say, a table and you're going to make a drastic change to that table. So your old data may not be directly transformable to the new change. So you can add your own SQL in here that should be run and for performing that migration process successfully. So yeah, now that we are running this process of generation, we not only get all the outputs from Nexus, but we also get the Prisma client, which is going to allow us to connect to the database safely, since all the methods and types inside are going to match our schema.prisma declaration. So seems like we entered into a loop in here. Anyway, let's close these files. Oh, my bad. Seems like I have forgotten to install this dependency. And from what I see, it turns out that we don't have the Prisma client yet. So let's add it. it should be the same version as the Prisma package that we added to the dev dependencies. And now we can see at the generation point that it's going to generate everything for Nexus and Prisma. Okay, yeah, it completed. All right, so let's do yarn dev. And it's gonna tell you that we are using the localhost / GraphQL. So if you actually open that in your browser, you're gonna see this UI where you can see the queries that we defined previously. Seems like we may have forgotten to export the mutations. Yeah. So let's update that. And as you can see, the restore process is going to take care of our server. That's why we set up that plugin earlier. And yep, now we can see the mutations. Now that we have Prisma set up correctly and that we have checked that our server works, we actually can start initializing Prisma as a client. I want to make the note as well that you should be following the naming conventions that Prisma recommends. That will make sure that the generation process works as expected. So if you have already a database which the name of the table in plural or with other thing that is not camel case, try to use this property map to map it to that name. But at the end of the day, you should have the same format of singular and Pascal case actually for the name of your models. You can find more about the good practices inside the Prisma docs. Okay, so now after stating that, let's create a clients folder in here. And inside clients, let's create prisma.ts. So we are gonna import from Prisma so this will be Prisma client, and then the approach is to define a singleton. So it will be const Prisma equal new Prisma client. And here as well, you can extend later on your configuration, but I'm just gonna go ahead with the basics in here. Export const Prisma. Okay, so I had created these. Now let's export. As you can see, it's just exporting everything from that file. Later on, we can add more clients, like to contact other APIs or databases even. So in here, let's go to the context. And this is going to be Prisma. The type is the class Prisma client. And the only thing left in here will be to add Prisma, which is going to be our singleton from the clients. Okay, so now, as mentioned previously, it's going to be passed to all our resolvers in the tree. So to do that, we need to get to the root of the tree. And in the index.ts, so inside the configuration, you can see context. So that will be create context. And if you remember correctly, this is going to receive the express context. So every time there is an incoming request to our API, it's going to create a context using this function, where there's going to be a singleton instance of Prisma, and that will be passed down the tree to all resolvers so that the operations can be handled on the database. Now let's go to our models to start using what we implemented. Let's define the relationships. So in here, for boards, we may want to list the items as well. So let's add a non-null list that's going to have non-null fields. And that's going to be items. And the type, it's going to be item. So the result it's going to be using the context that we just declared. And as we can see in here, we have access to the different models that were defined. So that's going to give you a lot of safety, at least more than declaring your own SQL queries. So if you make a change, everything will be generated again. Well, the process itself makes your API safe in the sense that no code is going to be possible to be built if it doesn't make sense with that declaration. So in here, we may want to just get board, find first. Or, well, this can actually be find unique. And the ID will be the ID of the root. And if we find any, we can return the items directly. And we may want to reject if we cannot find that. So let's add this. Okay. So now let's do the same for the other items. So I'm gonna copy these. This is not gonna be a list for board, but it's gonna be a list for both. Sorry. So in here, votes of type vote, and here's going to be an item, and in here, votes. Okay. So now we can worry about the other ones. We can do an item. And of course, that's not going to be a list, so let's remove that. Okay, and we're just going to return that item. Now let's just add the user. It's going to be of type user. User ID. Also, try to have your server running. This will make sure to regenerate everything for you. Okay. So looks like we have everything set up. Now we can proceed to the actual logic of our application. So let's go to these queries. We are going to return Prisma boards dot find many, and we don't care about filtering right now, so let's just return everything. And this is a non-null list of non-null words. In this case, it's going to return ctx.prisma.board. And here is where things are going to get interesting, because we need arguments to allow users to filter this. So in here, let's create an input. Well, actually, it's going to be a where clause. So the goal with this is that we can get filtering. And in here, it will be something like args.where.id. For proceeding with this, let's go to inputs and declare index.ts. And we are actually going to learn about another option from Nexus. So in here, there is an input object type. And we are going to be needing the filter for the specific board, right? So it's going to be board where unique input. And that's going to be an input object type. So just copy these. Keep in mind that this is a really common way to name the inputs for uniqueness. If we were looking for a more generic filter which may return multiple things, just take the unique out. We can take this, put in here, and the definition will be similar to how we define just regular objects. And here we just pass ID. And that's it. So let's just make sure that this is enforced all the time. Okay. So now I will export it and I can use it in here. So board where unique input, it's going to provide us what we need. Sometimes that happens. The code may have errors, and that makes the running process of our API fail. But if you run it again, it should be good. So as you can see now, there are no more errors on the syntax, and we have access to the argument that is being passed to the query. Now let's repeat the process, but for mutations. So in mutations, we need to pass information to each of these. And one of the best practices for the GraphQL APIs is to pass a single input. So if you have create board, the only argument that will be passed is input. And the name of that will be create board input. So it's always taking the name of the mutation and then adding the word input to the end. If it was something like update, like in this case is remove, well, the good practice for that is to add the where clause, and we will be passing the non-null board where unique input. So as you can see, we are reusing something that we already have. And well, now let's do the same for items. So in here, I'm just gonna change these to item. It's gonna be ID. Let's copy these actually into here. It's gonna be it's an item where unique input. Okay, so the next two things in here will be the create board and create board item. Let's copy one of these as reference. create board item input. Okay, so some times you need to be really careful on the things that you're passing to the input, because you may be allowing undesired behavior. So if there are some protected fields that you don't want your client to mess up with, just don't include it in the inputs. For this, of course, we don't want an ID to be sent. But what we do want is the name. Also forgot to put this in here. Okay. So we want the name and we want the description. All right, looking good. So let's copy this. And we need it for board as well. Board item is going to be more simple because it's just content. The one that has description is the board. So let's paste this. Okay, okay. Yeah, looking good. And now we can go back to our mutations. And it will be create board input. All right. And in here will be ctx.prisma.board.create data, and that's just gonna be args input. Okay. So let's run this again. For create board item is going to be similar, so just copy paste this. Board item input. Oops, my bad. Okay. And here, copy these. It's going to be item. And then input. But guess what? We are missing information. So in here, we don't know to which board this should point to. So we have two ways. We could put it inside here, or we could use a where. I'm going to use a where so that there is reusability in the code. And that will be board where unique input. Okay, so now in here, the board ID, it's going to be args.where.id. And taking a look at this, yep, it went fine. All right, so now if we did everything correctly, we should be having a functional GraphQL API. So the next step on this will be to test our result and see what's going on. Oh, wait, we forgot about vote item. So yeah, let's add that quickly. So this is going to be vote item, delete. This is going to be aware. And this is actually going to be equal to args.where. Oh, okay. Yeah, now it's fine. And in here, it's going to be item. For these, we are just, yeah. So we can do update or create, it's up to you. And here I'll be using create. The data in here will just be the user ID, which for now, let's just leave it empty. We are also going to be using the item ID. So in here, let's say args dot, oh, sorry. Yeah, forgot I renamed this. Args dot where dot ID. So ideally, when we implement authentication, we are going to be having a function that provides us information about the user. So that's what it's going to give us the user ID, and we can replace that. So for now, let's keep it simple and do not worry about that. And in here, we may want to just return a vote rather than an item. Before proceeding to testing our API in the browser, there is something else that I would like to mention. So right now we have the removal mutation, and that's gonna cause a problem since by default our model it's gonna detect a dependency of the items behind scenes. We need to make sure to set up something to tell the ORM that when there is an item being removed, all the votes of that item should be removed as well. So let's talk about how to do that. Usually, that's something that we defined when we are creating our database. So actually, the name of that in Prisma is referential actions. And with referential actions, we can achieve that same behavior pretty easily. The only thing that we need to do is setting the relations with that behavior that we want. So in here, in the case of vote, if we delete an item or we delete a user, we should be deleting this vote as well, right? Because otherwise the required dependency is not going to fulfill. So let's set in this relationship on delete, and this is going to be equal to cascade. Okay, so now we are telling that if the user gets deleted, then propagate that to vote. So it will be deleted as well. And in here, do this for item. And if we delete the board, it will make sense to also remove the items. Otherwise, we are not going to be able to access those items anymore. All right, so now that we have this in place, we can just open our terminal, kill the API, Prisma migrate def, referential actions. All right, so enter. It will apply the changes to our database. Let's make sure that the API is running. And in the browser on the playground, we can add a query to get the boards, and I want the ID, name, items, and for the items I want the ID, content. If we run it, we should get an empty list. Yeah, that's fine. So now let's add the mutation to create a board. So now let's run this. We should be able to see it in boards. Yep, that's right. Okay. And now let's do the same. In fact, I'm gonna copy paste this. And we want create board item. Input. Okay. And in here will be content. We also need the where. Okay, and this is going to be required. And here, let's add the where. Okay, and now in variables, and where we specify the ID of the board that we want. And yeah, we get the item. So in here should be reflected. Let's create one more. Yes. Now let's copy this into a new one. This is going to be for the vote. So vote item, we can remove this. And in here, we don't need the input, just where. And that can be just the item. Now let's be practical and just add the ID. I'm gonna take the ID of the second one. Whoops. So we got an error, and you may be wondering why. So as I was pointing out before, inside the mutations, we don't have a way to determine the user ID. And this is actually something good about Prisma, that is showing us this validation of what went wrong on the query. So what we could do in here is, instead of passing the user ID, we can say user for this item. And for item, we will be connecting to an existing ID. Whereas the user, it's going to be created. And then it's going to have just anything that you want. So let's put whatever in here. Last name, email, let's put a date. Since it's being unique, it's going to complain if we have other thing. So just the date, the email, and for this, we're going to need a password as well. So it's not ideal, but I mean, it will be changed in the future when we have authentication. So now let's wait until the API restarts and try it again. Okay, so now we should be having a new vote in here. So let's just list user ID. Okay, yeah, and we indeed get a vote for the second item. Let's add a new one. Yep, we got it. Okay. And now the last piece of this will be to remove an item. So I'm just going to copy the previous one. So I'm just going to paste the previous one. Remove item. And in here, under mutations, this should actually be item where unique input. Okay, yeah. Some minor mistakes, but it should be fine soon. Okay, yeah, so as you can see, the error went away, and now we only need to pass the appropriate variables. So it's going to be where the item that we want to remove is the one that we just voted on. So the ID in here will be this. Okay. So what's going to happen now is that this second item should go away along with the votes that are inside. Voila! Now the mutations behave as expected, and we have the first working version of the API. In the next videos, I will show you how to keep improving our API with exciting features. If there are any topics where you would like further explanation, let me know in the comments below, and they may appear in the next video. Don't forget to subscribe and share the video if you find it useful. Thanks for watching.